Materials supplied by Microsoft Corporation may be used for internal review, analysis, or research only. Any editing, reproduction, publication, rebroadcast, public showing, internet, or public display is forbidden and may violate copyright law.
Yeah, thanks, Professor Zhao, and I'm very glad to be here to present the research progress in Tsinghua University and partially funded by the Microsoft Research. And GlobalChangeOne is an ongoing project, multi-institutional, and brand new efforts in China to enabling the global change studies. Why global change is a pretty hot terms recently? Because even though climate changes naturally, but recently the rapid warming of the planet and it's changing atmospheric composition are widely thought to be due to human activities. That's the reason for why people so many efforts, national or international, focus on climate changes, understanding the past, the current situations, and the prediction of the future conditions. If we just focus on the climate data, the part, I would like to reference this specific, documents. Jonathan Overpeck publishes this, a good prediction on the science back to the 2011, and in this diagram, he did very good predictions. Oh, here we go. On the volume, expected volume of the climate data in terms of observed and also model output. So as we can see, the climate data is really a big challenges for us to deal with if we really want to do the global change studies. And here's a quote: the volume of the data, creating very big challenges on various aspects in terms of physical archive and sharing, and also ease of access. So here I would like to share you with an example, CMIP-5. CMIP-5 is a couple model intercomparison project. And in this phase 5.2, modeling centers from worldwide, have produced so far roughly about 1.5 petabyte state of model simulation data. And here's the workflows. We see some problems with the current data management with CMIP-5. So basically, modeling centers need to house the data and make them available, in a web-based environment. And then the PCMDI enabling a high-level architecture, we call it gateway, to on top of individual data nodes to enable data search and integrated data discoveries. But here's the exact workflows. Researchers need to go to the PCMDI portal to find out the data of interest, and then go to the individual modeling centers to grab the data and archive them in the local environment and finish the individual research process. So here is our questions. When the future, current and the future data volumes that will be produced by the climate changes, do we really want to transform the so large volume of data online? So that's the one direction of our research. The second, if we also focus on the life cycle of research process, basically data discovery, archive them locally, and then finish analysis. So far we believe the research paradigm, we call old paradigm, is kind of this way: provider on the left and the user on the right. So provider basically for 3 roles and left all the others to be fulfilled by the users. So that's we can see users need to download data and archive locally and finish all the necessary process after that. So that's we call everything locally and shared, everything locally owned and operated. This is the old paradigm. So we believe a new emerging paradigm is out there. We can see, besides the traditional role of provider users, we also see the new role of integrators. They are not general. They are not the providers. They do not produce the research data. On the other hand, they are not the consumers. Instead, they play the sitting in the role and try to enabling easy of access, provide some solution and research environment and directions and solutions. So as we can see, this new paradigm, providers still fulfill the 3 roles: archive data and make them available, while the integrators play more roles. They make the data easy access and make the research publications out there. So what left is for the users. We believe just focus on science. So that's our dreams of this new paradigm. The third direction is kind of a reproducible research. This is a publication back to the 2011. It talks about how and why research need to be reproducible. This is a reproducible research in computational science, and in this reproducibility spectrum, we can see on the very left side, if we only publish our research results as publications, this style is definitely not reproducible. So this point of view is very interesting because back to the scientific gold standard, research need to be reproduced. However, if we only publish the research results as we do right now, it's not reproducible at all. So totally, if we focus on the life cycle of data, life cycle research, and also focus on the reproducible research, that's the three dimensions that we try to deal with. So GlobalChangeOne is a brand new effort in Tsinghua and 5 other institutions. We are trying to build a research infrastructure dedicated for global change studies. Here's our vision. We believe such a research infrastructure is vital and is dedicated for the global change studies, making possible discovery innovations and also accelerating scientific insights. This GlobalChangeOne efforts will have some important characteristics. Data resources will be shareable online, and software packages and codes. And more importantly, this will be an integrated research environment for the researchers doing global change studies. And we have come up with this multi-layer architecture on top of the collaborative research partnership we have established with some other institutions. We have also identified some other necessary functions that we need. If we focus on the computing and storage facility, so far we have purchased and hosted large-scale computing facilities and storages and web server and a computer node. That's just hardware part. And we focus on the software part because right now we have 4 research streams in the Tsinghua: remote sensing, global climate model, ecological studies, and microscience. So computational earth system science closely collaborating with 4 research streams, and we have identified those problems in individual disciplines individually. So right now we are making some good progress so far for the remote sensing and for the global climate model, ecological studies, and atmospheric studies. And here I would like to highlight our most recent effort to put CMIP5 on Azure. This would be a CI state out portal based on the Windows Azure public cloud computing platforms. CMIP5 at Azure is a new effort with collaboration and funding from Microsoft Research. We're just focusing on the CI data. And so far we have archived all the CI data produced by the modeling centers during the CMIP5, during the phase 5 of the CMIP. And then we're enabling integrated data archive, search, and visualization, and intercomparison environment, so powered by the Windows Azure. So researchers who are interested in the analysis of the CI data may go directly to this data portal, and I do not think they need to download data locally because we try to provide the necessary functions out there, so everything should be work online and on the fly. Basically, the CMIP5 CI data portal have a three-tier architecture. On the back end, we put all the CI data in Azure blob storages, and in the middle, we enable the virtual machines and plot the Tomcat and NCAR command line language and Java out there to enabling virtual research environment. And on top of that, we provide a web interface on top of that, so the users may search and analyze and compare the CI data portal. I guess I have more minutes. I would like to show this demo to see whether we can do it. I guess I have some problem with copying this URL, but I guess we can do it later, right? Okay, because I have several more minutes. Basically, this is a brand new effort on Windows Azure. We try to upload the CI data produced. Yeah. No, not this one. 我想把那 URL copy 下来可以吗？哦 ，URL copy 下来。对，就是那个，对，copy 打开这个。对，但我想输入进去，可以吗？ 对，就在下面玩呀。
你先讲。
Okay. So basically, we archived the CI state produced by different modeling centers worldwide and put them in a Windows area archive, and then enabling a virtual environment on top of that. And then we enable an interface on top of that, so users may interact with the data archive and analysis functionalities out there. I don't know whether I can do it, They have a wireless here, right?
Aware network.
But I guess we can do it later, okay?
Okay.
Yeah, thanks.
说说 video.
How to?
你到 video 是吗
No, 不要，就这样。
Okay.
Thanks. And so far we have enabled these three types of functions. Users may go to the interface to search for the CI state of interest, and they may define the model and define the time of interest, the beginning month and end month, and then they could quickly visualize the data of interest. And on top of that, they could select individual data and then do the intercomparison. So data search, visualization, and comparison are well done on this Windows area-based interfaces. So I believe people, whoever interested in the CI state analysis, could go to the portal directly and fulfill the analysis online. So we hopefully this brand new efforts will make it easy for the scientists to analyze the CI state produced in the CMIP5. So far, I would like to share with you my lessons learned from these activities. We believe focusing on the life cycle of just not only the research data, but also the research process is very important. And that's the reason we have so many things to do. And also, besides traditional role of providers and users, we believe an integrated role is very important, because that will make it easy for the individual communities. And third, we believe a new web and a service-centric paradigm is pretty important and is emerging. I believe that's part of the reason that we are sitting here today. Sharing the research data and also the research results is just the beginning. I believe the fundamental goal is to share the research process, so we know the stories working behind the scenes. And that's the reason we could promote the reproducibility of research process. Doing science on the cloud is very beautiful. However, I believe nobody wants to change the environment to do the migrations from time to time. So we argue that provide web-based, cloud-based research environment, and that is users are very familiar with, is a key to bring and to attract scientists to doing sciences in this new paradigm. I mean, instead of focusing on the research environment, trying to leverage resources on the cloud, but we need to provide a research environment that they are very familiar with. So that's the reason in this CI state portal, instead of leveraging the brand new program model like a work role and a web roles, we also enabling virtual machines and enabling in-car command languages. Because these are the languages that researchers who are doing CMIP5 data analysis working all the day in a local environment. So we could name a very long list that we need to thank, but here I just name a few. Thanks Tony Hay for visiting us, delivering talk again, and broadening our horizons. And thanks Dan and Dennis for their support of efforts on the experiment online. And also we need to thank those who make the connections, like Ms. Xu and Kamping and Ting Ting. And with that, I'm ready for any questions.